Hi. Now in this question we're given that the curve with equation y equals x squared minus 32 multiplied by the root of x plus 20, where x is greater than 0, has a stationary point P. And we've got to use calculus for the first part to find the coordinates of P for 6 marks. And then in part B go on to determine the nature of the stationary point P for 3 marks. So if you'd like to have a go at the first part here, and haven't done so already, just give you a moment to pause the video. Okay, welcome back then if you had a go. Well, for part A then, let's just copy down the question. We've got that y equals x squared then minus 32 multiplied by the root of x and then plus 20. Now to get stationary points, I need to differentiate this and set the gradient equal to 0 and then work out what the value of x is that gives us that gradient of 0. So to differentiate this, I don't like that root x being there. We'll change that to x to the power half. So we end up with minus 32 x to the power half and then plus the 20. So when it comes to differentiating this, therefore dy by dx, differentiating this in the usual way for terms like this gives us 2x. Then for this term, multiply the half with the 32 gives us minus 16, and then reduce the power by 1, so that's x to the power minus a half. And then when it comes to differentiating a constant, that goes to 0. Now because it's got negative powers in, I'm going to rewrite this. We've got 2x. Now this will be minus 16 multiplied by x to the minus a half. X to the minus half is 1 over x to the power half. And so that's going to be 16 over x to the power half. Now we know that at stationary points, let's just mention it here, we should know then that at stationary points the gradient that is given by dy by dx has to equal 0. So that means that our equation here, we'll put it therefore, that equation 2x minus 16 over x to the power half, or you could write the square root of x, up to you, equals 0. So coming down here now, we need to solve this equation for x. And there's various ways that you could do this, but being a fractional equation, seeing that we've got x to the half here, I want to get rid of that fraction, and I'm going to multiply both sides by x to the power half. So we'd get 2x to the power 1.5. Remember, you have to add the powers, so it's 2x to the power 1.5, 3 over 2 then. Multiply this term by x to the power half and you just get left with minus 16, and 0 multiplied by x to the half, well that's going to equal 0. I'm going to add 16 to both sides, so therefore 2x to the power 3 over 2 must equal 16. Divide both sides by 2 and that gives us x to the power 3 over 2 equals 16 divided by 2, which is 8. And at this point, to work out what x is, remember this x to the power 3 over 2 means the square root of x all cubed gives us 8. So in order to get x, we've got to do the opposite. Instead of square rooting, we've got to square both sides. So that's going to give us 8 squared. And we cubed here with the 3, so to do the opposite, we've got to do the cube root. So we've got to take the cube root then of 8 squared, and that will give us x. Well, 8 squared is 64, and the cube root of 64 is 4, so therefore x equals 4. And we need to find the coordinates of this stationary point P, so we need to find out the y value when x equals 4. So when x equals 4, all we've got to do is substitute this into our equation for y, which will take this one up here. So it's just going to be 4 squared then minus 32 times the square root of 4 plus 20. Now if you work this out, this comes to minus 28. So therefore, the coordinates of the stationary point P are x equals 4 and the corresponding y value is minus 28. Okay, so that's part A done. Now for part B, we've got to go on and determine the nature of the stationary point P. Is it a maximum, a minimum, or even a point of inflection? So again, if you'd like to have a go at this, just give you a moment to pause the video. Okay, welcome back then if you had a go. Now there's two possible ways that you can determine whether P is a maximum, minimum or point of inflection. And I'll show you both ways. The first way I'm going to show you is by drawing a gradient table where we take x and we look at the gradient given by dy by dx for the point where x equals 4, and then we take a point slightly to the left of 4 and a point slightly to the right of 4. So if we take where x equals 3 to the left and say x equals 5 to the right, we know that when x equals 4, dy by dx comes to 0. Now if you were to substitute x equals 3 into dy by dx, this equation here, 2 times 3 minus 16 divided by the square root of 3, you'd find, if you did it on your calculator, you get a negative value, minus 3.2 roughly. Okay, there'll be some other digits there. When you substitute 5 into dy dx here, you'll find that you get a positive value, 2.8 and so on. So what does this mean? Well, if we look at the slope of the tangent to the curve, we see that when you're to the left of 4 you get negative values. That means the curve is sloping downwards like that. Any tangent drawn to it will be going down. At 4 it's 0, so it's horizontal, and at 5 it's positive, so it's going upwards. So clearly what we've got at point P is a stationary point which would be a minimum point. So that's one way that you can do it. It's not the way I would generally go about it. The other way, I'll just put here or, is to work out what the second differential d2y by dx squared is. And by this method, we substitute x equals 4 into the second differential. If it's positive, it's a minimum. If it's a negative value, it's a maximum. And if it's 0, it's inconclusive. So I'm just going to differentiate dy by dx again then. What we'll do is I'll take this version here. So if you differentiate 2x, what you get is 2. And differentiating minus 16x to the power minus a half gives us plus 8. That's minus 16 times minus a half. Reduce the power on x by 1, so that's x to the power minus 3 over 2. Now because this is a negative power, I'm going to rewrite this as 2 plus 8 times 1 over x to the power 3 over 2, which is going to give us 8 over x to the power 3 over 2. So all we need to do now is just substitute in our value of x, that is when x equals 4. And when x equals 4, we find that d2y by dx squared comes out at exactly 3, okay, which is a value greater than 0, a positive value. And if it's a positive value, it tells us that we have a minimum. So therefore, whatever method we use, P is a minimum. Okay, so I hope that's given you an idea then how to go about that if it caused you any problems. Don't forget, you can always see tutorials on this on my website.